Okay, guys, today we are starting our unit on simplifying square roots. Okay, in the first section, we're going to look at no perfect square factors in the radicand. Okay, this should look pretty familiar to us because we've done some work with this in prior units. And remember what our perfect squares are and trying to pull out perfect squares from numbers that are in the radicand. Okay, so when we look at our simplest radical form, it involves no perfect square factors, no radicals in the denominator, and no fractional radicands. Okay, so first of all, we probably need a little refresher on the actual parts of a radical. Okay, the end there is what we call the index. Okay, so this is the index. Usually we don't see a number written here because it's assumed that it's a square root, which means it's a 2 there. Okay, this actual sign here, the green check mark looking divisible sign, that is the radical sign. Okay, remember, this is not to be confused with the actual like long-term division that you guys used to do by hand when you were in middle school or whatever, maybe elementary school. Okay, this is the radical sign. Okay, now the stuff that's underneath the radical sign is the radicand. Okay, you guys have seen this part before, so hopefully this is more of a refresher than something new. Okay, now perfect squares, hopefully we remember a good chunk of these too. 1, 4, 9, 16, 25. And remember how we're getting these numbers. Okay, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on and so forth. Okay, so take a second, get these perfect squares down. Okay, go ahead and pause the video if you need to get all of these down. Remember, the way we get these is just by multiplying our numbers by themselves. 5 times 5 is 25. 6 times 6 is 36, and so on and so forth. Okay, so take a second, pause the video if you need to copy these down. Okay, the product property of radicals, again, this should be fairly a refresher for us, for most of us, I would think. Okay, if we have the product AB in the radicand, okay, we can separate them to the square root of A times the square root of B. And this is going to be super important when it comes to actually taking out our perfect square factors in the radicand. Okay, so let's look at some examples here. Number 1 is the square root of 32. Of course, we know the square root of 32 is not a perfect square, but we want to ask ourselves, is there a perfect square that goes into 32? And of course, we should all be saying there is. It's 16. So the square root of 16 times the square root of 2, this is our product property that we were looking at. And of course, we know the square root of 16 is 4. So our final answer would be 4 root 2. Hopefully this is looking familiar to us because, like I said, we have done this in the past this year. For number 2, I have the square root of 63. We want to think of the highest perfect square that goes into 63. And of course, we would all say it is 9. So I have the square root of 9 times the square root of 7. Remember, it's probably good practice to always write that perfect square factor on the left side here, just because then you already know where to look. Okay, so when I change this, because I'm going to end up changing this, because the square root of 9, 9's a perfect square, would be 3. So 3 root 7. Okay, on to number 3. Number 3, I have the square root of 242. Of course, 242 is not a perfect square, but we want to try and find out if there is a perfect square that goes into 242 evenly. Okay, of course, 121 does. So I'd have the square root of 121 times the square root of 2, and hopefully we know what the square root of 121 is. If not, take a second with your calculator, put it in there, and see what we get. Okay, hopefully we got 11 root 2. Okay, so again, hopefully these are kind of more of a refresher to us than something new because we have looked at this earlier in the year. Okay, remember, if we don't have a perfect square in the radicand, we want to find the highest perfect square that goes into this number. Okay, 32 is 16, 63 is 9, 242 is 121. Okay, our next 3. Now I have a number outside of my radical sign. Okay, I have 2 root 75. We're going to find out how to deal with these too. So really, it just kind of comes along for the ride in the first step here. 2 times the highest perfect square that goes into 75 evenly is 25. So 2 root 25 times root 3. Okay, that part seems pretty simple, right? We're just bringing the 2 along, and then we're doing exactly what we did on the last slide with 75 here. This might be where it's a little new to us. Okay, again, 25 is perfect square, so we can change this. The square root of 25 is, hopefully all of you guys said 5. So I would have 2 times 5 root 3. Now, hopefully, we know that when 2's written right next to something like this with no sign in between it, it's implied that it's multiplication, okay? So 2 times 5 is going to give me 10. 10 root 3 would be my final answer here. Because 2 and 5 are both outside of the radical sign and I'm multiplying, I can multiply them and combine them to give me a 10, okay? So since they're both outside of the radical, 2 times 5 is going to give me 10. 10 root 3 is my final answer, okay? Now, number 5, I have the negative square root of 500. Again, this negative sign is going to kind of just come along for the ride when we do our first step here, okay? Hopefully, we can look at numbers like this, like 500, and already know what the highest perfect square that goes into it evenly is. 100 is probably a pretty dang safe bet, okay? 100 goes into 500 5 times, and of course, 100 is a perfect square. So the square root of 100 is, hopefully you guys all said 10. So I would have negative 10 root 5. The reason we didn't show this extra step like we did over here is because a negative 1 times a 10 is just negative 10, and that can be pretty easily done without showing that step. Okay, so my final answer for this one would be negative 10 root 5. All right, number 6, I have 5 times the square root, excuse me, of 432. I need to find the highest perfect square that goes into 432. Okay, so what you can do here is you can start dividing 432 by that list of perfect squares that you created on the first slide. Okay, so I have 5 root 432. Well, the highest perfect square that goes into 432 evenly is 144. So I would have 5 times square root of 144 times root 3. Well, hopefully we all know 144 is a perfect square and that the square root of 144 is 12. So I'd have 5 times 12 root 3. Well, 5 times 12 is going to give me, hopefully you guys know this from like a clock, right? How many seconds are in a full rotation of the clock? 60. So my final answer would be 60 root 3. Okay, so the only kind of new thing that maybe we're not used to seeing a bunch is this number outside of the radical sign. But really, it's just going to come along for the ride, and we're going to end up multiplying it by whatever our perfect square turns into. So in this case, it was 5, and we multiplied it by the square root of our perfect square, which is 144. Of course, that is 12. 5 times 12, 60. Okay, same thing over here. 2 times whatever the square root of 25 is. We know that's 5, so 2 times 5 is 10. Okay, that is it for today's lesson, guys. Let us know if you have any questions.